Hey, Vlad here, devinsideyou.com. Welcome to another video. In the previous video, we pretty much revamped the entire implementation of the sets that we had made in the video before that. Today, we're gonna learn about Varargs, which is a syntactical construct which allows you to create to define methods with multiple with a sort of like an endless amount of arguments that have the same type. And in addition to that, we're going to revamp the entire implementation again. I'm sorry. So we're back in the virtual machine, and let me start SPT, and we have Sublime at the top, this time the same as before in the previous video, and let me run the test. So what we did was we introduced this non-empty thing, right? So we had this, where is it? Where did it go? Non-empty, right? Which gave us sort of like this link, so that we could always, like, if we had an element, we could always sort of touch at the next element. And what happened was that we implemented a bunch of methods, and if you look at them more closely, the implementations, not the declaration, then you will see that they're pretty much the same. And what I mean by that is that they have a very similar structure. So what they do is always they do something to the current element, and then they pretty much do the same thing to the other elements, right? So for example, I don't know. Let's look at union, right? So it adds the current element to that, and then it calculates the union with the other elements, right? Let's take it into an intersection. It calculates the intersection of others, and then it adds the element, right? And this one, it calculates the difference of others, and then it adds the element. Sometimes, there are some conditions, obviously, but basically it's always like, let's do something to the element, and let's do the same thing to the element, to the other element, or like the similar thing. Always like hash code, size as well, right? Let's calculate, let's add 1 for the current element, and let's calculate the size of the other elements, so on and so on and so on and so on. So what we're going to do today is we're going to find a way to abstract over this, right? So basically there are two things that are happening in each of these methods. One is we're applying some function to the current element, and the other thing is that we're walking through the elements, right? So basically we will try to rip out this walking through the elements, this traversal, and put it in its own function, and it will be a higher order function, right? It's going to be called for each, and it will take as a parameter another function, right, which will be applied to every element. So it will make sure that this walking through the elements is being taken care of, and then you will just, as a client, will just provide what it has to do with each and every element, right? So we're going to call it for each because that's how it's called, and let's add a few tests for it. Let's go down over here, and let's just add a test, right? Okay, so remember, we're implementing a function that takes care of traversal, and in an empty set there is nothing to traverse. So we want to make sure that whatever function we're going to pass it in to pass to for each, that it's not going to be applied, right? So basically what we're going to do is we're going to create a function that throws an exception, and then we're just going to make sure that this exception is not thrown if we call for each on an empty set with this function, right? So we're going to say for each on an empty set should not apply the function, right? So what we're going to do is we're going to say no exception should be thrown by, which is something that comes from Scala test, set.empty dot for each, and as I said, for each is a higher order function, so it needs another function as parameter, right? So you're going to say, okay, so whatever element you have in your hand, wherever the current element is, just throw an exception. So this arrow should not be thrown, right? So as of right now, it's not even going to compile because we don't even have the for each method, right? But we're going to add it. Let's just go here and add it over here. So we're going to define for each, right? And for each, as I already said, it's going to take a function as its parameter. So let's just call it function, and we're dealing with sets of strings so far. We still haven't derived the generics, right? So we have a function that takes a string and produces a unit, right? And the result type of for each is also going to be a unit, right? Okay. Actually, there will be no implementation. This is just an abstract thing. Okay. So as always, we duplicate it, we bring it down over here. Final override that for each equals, as of right now, nothing. Duplicate this line. Remember, it's still one line to Sublime, even though it shows it as two lines because we're wrapping it automatically. All right. So at least now it should compile, but now just throw this exception. All right, so all that this test requires is that we don't call this function. Well, okay, let's not call this function, but we still need to produce a unit somehow, and the way you do it is just by doing that. Or, you know, we could also use curly braces, right? So now the test should pass because we're not calling this function. So this test was, you know, kind of obvious, but believe me, it is really necessary. Okay, let's add the next one. So for each on a non-empty set should apply the function. Very similar. Now, how do we test that the function is applied? Well, we're going to have a variable, function was applied, and it's going to be equal to false. Then we're going to create an empty set. We're going to add some random string, right? We're going to call for each. We're going to pass it a function that takes every element, and it pretty much ignores it. But all it's going to do is it's going to take function was applied, and it's going to set it to true. Right, so this is how we will know that the function was applied if this variable is true. Right, so after this we can say function was applied should be true, and as of right now it should fail. There we go, it fails. So now let's fix it. So we're gonna go to for each over here, right? So all we need to do is we need to apply the function to the current element. Right, so we also need to traverse the others, but I believe in this one we only have a task for this one single element. So let's just keep going and make it fail. So we're gonna have another test for each should be able to calculate the size of the given set, right? Okay, so we're gonna have var size equals 0, right? And we're going to do set.empty dot add. Actually, let's do this first. Let's do it with an empty set first. Okay, maybe it's not necessary, but maybe just like to make it more clear. So we're going to set for each size plus equals 1. It's very similar to what we just did, right? So size should be 0, and also size should be set.size, right? So we're gonna save this into a set, right? Gonna set for each, right? There we go. Okay, so what does it say? Expected blah 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 blah. Where? What? Oh, here. There we go. All right, should be, and I'm gonna let Scalariform do its magic and fix this brace for me. Okay, or that. All right, there we go. So now everything is green. Now actually let's test this was more than one element, right? So for each should be able to calculate the size of the given set. Actually, I'm gonna call them all the same. I'm just gonna call this one 1 and this one 0, right? So what I want to do is I want to have a size of 0. I want to say set.empty dot add. Actually, let's do the same thing as before. So let's have a set dot add random string, random string over here, right? So now let's do the same thing. Basically, I'm just going to copy that. I'm going to put it over here, right? So now it should be 1. Because we already have the size implementation, we actually don't need this. But this is like a bit more explicit. Okay, let's do this with 2 elements, and this is the first time where it should actually fail, right? So we're gonna say 2. We're gonna add another one, random string, right? And there we go. This one finally failed. Oh no, hold on, I forgot to fix it. Okay, there we go. It should be 2. All right, but now this actually fails, right? So, and this fails because we're actually not applying the function to the other elements. So all we need to do is we need to say other elements for each not element function, right? So we're applying the function to the current element, and we're applying the function to the other elements, right? Very simple. Now this is pretty much exactly what I said before, right? But now it's like very explicit, right? Oh, look at all of these. They were applying, they were doing something to the element, and then they were doing basically the same thing to the other elements. But this way, it's way more explicit. Let's also add another test just for fun, even though you know, we already know that it's going to pass. You know, let's make sure that if we add the same element to the set, that the size will remain 1. Now the test is called 3, but not because the size is 3, it's just because it's the third test. Well, technically it's the fourth test because it was a 0, but you know, you get the idea. Okay, so let's add the same element. All right, so let's have an element equals random string, and let's just make sure that we're adding it twice, right? But the size should still be 1, right? Because even though for each would go through all the elements, but add, make sure that, you know, there's not 2 elements but only 1. All right, so before we continue, let me actually show you how to implement a method in Scala that can have an arbitrary amount of parameters, which is called Varargs, so like for variable argument list, probably, or something like this. So the idea is that we're going to go to set, to the companion object of set, which is, you know, this big one. Like everything is in the companion object of set. Actually, let me collapse that, and let me collapse that, right? So this is, you know, this is the companion object for the sets. And what we want to have is we want to have a function called apply. We're going to write tests for that in a bit. So what we want to have is basically I want to be able to say, actually maybe this is why we should write a test. So let's actually write the test first. So I didn't save the file, so everything should still compile, right? So let's say calling the varargs apply method that we're going to create in a second, right? On the set companion object should yield a set with all the arguments as elements, right? This is what we should do. So basically, if we have A, which is a random string, we have B, which is a random string, we have C, which is a random string, right? Then if we do A, B, C, right, this is where we're calling this apply function, and there will be a magical syntactical construct that will allow us to pass as many arguments as you want, right? So this will compile, and this will compile, and this will compile, right? So so this way, because we already have equality defined, right? So this should be exactly the same as adding A, adding B, adding C, right? So now it's going to say, hey, you know, this the apply doesn't take parameters. Okay, so let's create it. So the way we create it is basically by saying that, okay, first of all, it has to return a set still, right? And I just want to make sure that it compiles, right? So what we're saying here is basically, give me the element, which is a string, and then we just add a star. That's all, right? And because it's a star, it means that it will compile if you don't pass. Actually, let me switch back to compiling real quick. Let's compile. Okay, let me save that. Okay, therefore, so now it compiles. So let me show you this. So now you can do set this, right? Now you can do set blah, or you know, whatever. I just typed something, right? Now you can, whoops. Now you can also do set of this and that, and you can just keep going like this, right? So this is essentially what it will do, right? All of this compiles. All right, so let me remove that, and actually before I make this task pass, let me actually ignore it for now, and let me run the test. So what I want to do is, anytime you're giving your users 2 ways to do something, if it is possible to give them only one, you should do it. It makes the library more simple, because every time they will see those 2 things, they will ask themselves, okay, what exactly is the difference? Is there no difference? And they will have to dig in, they will have to look at the implementation or at the documentation, which we will probably not have, let's be honest, right? So what I want to do is, I want to forbid the creation of empty sets by passing nothing to apply, right? So basically, I don't want something to compile. I want that this way should not be possible, right? So I want to say that this should not compile, right? Because if you want to create an empty set, just do this, right? I don't want set to empty, you know, set without parameters to compile, right? So I'm gonna say this should not compile, right? But now it says that it actually compiles. Expected a compiler error, but got none for code set. Okay, so it didn't get a compilation error. So the trick is to rename this to other elements, right? And to have another element over here, right? So now we're forced to always pass this argument, right? And if we want to, we can pass 0 or more arguments over here, right? So now at least this test should pass. Right, now it passes. Okay, so now set doesn't compile, right? We can actually do this, right? So if you do this, now it doesn't compile. It says not enough arguments for method apply, unspecified value parameters element and other elements. So now we haven't specified either of them. Okay, right. Okay, so let's actually try to make this test work by implementing the apply over here. All right, so what we want to have is, oh, now that looks weird. All right, let's do that. Oh, it actually is on that line. Okay, this is confusing. Hold up. Oh, let me do this. All right, there we go. See, this is why, like, usually you don't wrap, you don't let you know, your editors automatically wrap source code, because it's kind of weird. But you know, I want you to see like all the code, because I don't want to like scroll horizontally. Okay, so what we're gonna do is we're gonna calculate a result. This is going to be our resulting set, right? So the result is going to be a set, and by the end we're going to return the result, right? And in the beginning, what we're going to do is we're going to take an empty set, right? We are already inside of set, so we can just say empty, and we're just going to add the element, right? And now what we're going to do is we're going to walk through other elements. Now, how can we walk through other elements, right? This is like this weird, like, is it a string or what is it? Well, it turns out that as soon as you're inside of this thing, then other elements has actually a type of sequence of strings, right? So all of a sudden, this is a regular Scala collection, you know, the one from the Scala collection library. It's Scala collection immutable sequence probable list. It doesn't really matter. What matters is that it also has the for each method, right? So we can do for each, right? So this is not our for each, right? This is not ours. This is the one that is defined on Scala collection immutable. We'll actually see it in a second. In fact, let me just do this. Let me just do other elements dot. Let me print line. Let me print line other elements dot get class dot get name. Now this is not the type, this is going to be just a class, but still. Okay, so we're going to walk through every element, right? And I'm going to use the syntax now, right? So we're going to take every element and we're going to change the value of result, right? This is a mutable variable, right? So we're just going to add the current element, right? So every time like we're touching a new element of this one, right, we're reconstructing the entire set, right? So we go here and we're just going to do to whatever we did before, we're just going to add one, and then whatever we did before, we're going to add one, and whatever we did before, we're going to add one, and then in the end, when everything is accumulated, we return the result. Now this is very imperative, very mutable code, and in the next, or maybe the video after that, we're going to get rid of all of that. We're going to have like absolutely zero vars, like maybe in the test, but not in our production code. Right, so I hope this is clear. We're basically walking through all the elements that are being passed in over here, and we add them all, and we start by adding this one. Okay, so let me see the print line. Print line is over here. Scala collection mutable wrapped array of ref whatever that is. Hold up, I actually don't like what I'm seeing. Let's try this. Val test equals that, right? So now it should compile. I'm just going to try to annotate the type. So if I were using a proper IDE, you know, I would actually see the type, but I don't. So let's do Scala collection immutable, probably set. No, not set. It has to be a sequence of string. Probably it should be like this. Okay. Oh no, I don't need the get name. I just need other elements. That's what I need. All right, found a sequence of string requires sequence collection immutable. Okay, so this is the real type. Okay, so this is the type Scala collection sequence of string, right? So other elements has exactly this type. Okay, let me remove that now because we actually don't really need to know that. All right, so let's get back to my main point. So now that we have a way to traverse all the elements, right? So we have a way to walk through all the elements. Now let's refactor each and every method and make sure that it uses for each. Right, so let's go to where is it? This is the set, this is the object. Oh yeah, I collapsed them, I forgot. Let me open them, and let me open this one as well. All right, apply. Okay, so instead of doing something to the current element and then doing something to the other elements, all I want to do is we want to call for each, and we have already seen how to do this. Actually, I'm gonna copy that like this, and I'm gonna comment this out because I want you to see the current implementation as well, and the previous implementation as well. Okay, so we're gonna have a function like this over here, right? And actually, let me fix the indentation real quick. In fact, you know what? We're not gonna touch the test anymore. So I'm gonna do this so that we see as much as possible. Okay. Okay. So we're gonna have the same pattern as before. So we're gonna start with a result, which is false, right? So for each takes care of walking through all the elements, and even if it's an empty set. So we're technically in the implementation of non-empty, but we will see in a second that we're actually also taking care of the empty set. So the result that we will start with, you know, and as always we will return it back, right? You will see that we will actually do this pattern for every function, right? It has to be whatever the empty set is doing, right? So if we go down to the empty set, the apply for an empty set is false. So this is what we will start with, right? So now all we will do is we will call for each. Right? We'll pass it a function that has the current element in the end, so it knows how to walk through it, right? And it will do this: result equals result. So whatever's, you know, being accumulated have been accumulated before, or so now instead of calling other elements, we don't need to recurse here. For each will do this for us. Okay, so now we just say current equals input, right? So we're just comparing this one to this one. And if our test is still passing, then we're done. What is interesting to know is that we technically don't need this split anymore for the, you know, we don't need to have the implementations for the empty and non-empty. We don't need to distinguish between them anymore. Let me show you what I mean. First of all, we don't need this anymore, right? Let me remove the override. Let me cut this out. I'm gonna cut this out from the non-empty, right? And I'm gonna go up, and I'm just gonna paste it in over here. Oh, actually, this one still can override stuff. So we're gonna have final override like this. Okay. So now this will not compile because in the empty version we're still overriding it right over here, even though I forgot to add final override. Right. So now if I remove this, our test should still pass. Right. Everything still passes because for each takes care of traversal even if it's an empty set. Right. Let's keep going. What is the next one? The next one is add. Okay, so let me, let me comment this out like this. Let me actually duplicate this line. Duplicate. What the hell? All right, let me duplicate this line. Let me uncomment that. Okay, go like this. And as always, we will always have this. We're going to have var result, which is going to be the same as the empty one. And what is it doing for the empty one? It is just doing that. Like that. Okay. And now we're going to do for each. Well, actually, let me return the result first. Because this, as I said, this will be the structure of every single method now. Okay. So I'm going to do for each current. And pretty much the same as before, right? We're going to say if current equals input. I'm gonna, I flipped them a bit because it's just kind of nice to read like this. So if current equals input, then don't do anything, right? Then don't do anything. Otherwise, do the non-empty of current and of the result, and let's see. Okay, 14 tests fail, which means I did something wrong. I did something wrong because I forgot to do this. Result equals. Right, so this takes care of producing another set. Basically, it creates another set with the current element and whatever the result was before. So basically, this is adding a new element, right? So this is the add function. And by the way, let me flip this so that we don't have this weird thing over here. So I'm just going to say, so only if it's not, if it's not the same thing, only then edit, right? So now we don't need the else, right? It's going to look like this. Very imperative code. As I already said, we're going to get rid of it eventually. And the same as before, we can remove the override, and let's actually remove that. Right, it's a final def now. We cut it out. We bring it to the top over here. We have final override def apply. Now we're gonna have a final def add. We're gonna go down at the very bottom. Just remove that. And if everything is still green, then we're good. We're not green because we're accessing non-empty. And non-empty is inside of the object set. So we're gonna do this actually quite often, and therefore over here I'm just gonna import the companion object, right? So I'm just gonna import set, and now this will be in scope, and now it will be fine. It should be fine. The conflicting method add was defined at line 16 line 16. Oh, I forgot to remove it over here. There we go. There we go. Okay, so everything is still green. Okay, so let's keep going. I don't want this video to be as long as the previous one. Let's just keep going. So we basically already know that it will end up like this. So, okay, so let's just remove the remove method. Let's go down to the remove over here. Remember, by default it removes this. Let's remove that. Let's go cut out the remove. Let's go put into the set over here. It doesn't override anything anymore, right? And let's implement it by using for each. Let me bring this up, but I'm going to comment it out, right? So for each, so as always, right, we have var result equals this, as always, right? And then we're going to do a result. As always, I mean, because the empty one was doing this, right? So now we're going to have for each current, right? And now we're going to have the implementation of that. In fact, I just didn't make a mistake because I blindly copied this from set.empty, but it actually has to be set.empty, right? Because for set.empty, this didn't really matter, but the default should be set.empty. We're gonna do this. Okay, so we're starting for add. We're starting with a non-empty set that already has this element, right? So basically, in the beginning, if it's an empty set, we're just gonna start by a non-empty set where we're just added, right? And over here, we just start with an empty set, right? With set.empty. In fact, we can do empty here and empty here because now it's in scope, right? Actually, let me remove that. I want you to witness this. Look, the result is like this. The result is like that. So the difference is the result, but the function itself is going to be the same. It's green. How crazy is that? This is sort of like a sign that you know, the essence of sets is this basically this duplicate thing, right? So because it's the same, like adding and removing, you know, it's sort of, there's something bigger there, you know, that's all I mean, right? Okay, so basically we start with an empty set, and then we walk through whatever we currently are, right? And if what we're walking through is not the input, then we're creating a new set which contains it. As soon as it's the same, then we just leave it out, right? So we're constructing a new set. We're adding everything that is not input, right? So it's in a sense it's the same as add, right? So for add, we're rebuilding the whole set, and for remove, we're rebuilding the whole set but without this element, right? It's kind of beautiful, actually. This could be abstracted away even further, but I don't want to waste your time, so let's just continue. Okay, let's continue with union. So I'm going to remove the abstract thing. We're going to go to where is it? Let's go down to this one. Okay, so union is that. So remember, this is going to be, you know, var result equals that. This is going to be the first line that we're going to have. Okay, so let's remove that. So union is over here. Cut that out. Bring it over here. That's where it was. Okay. It's not an override anymore. It's just like that. Okay. And let me leave that just for a second. Okay. Okay. So as you remember, var result was that. You know, this was the, you know, the one in the empty one, and we're going to return result in the end. Okay. So let's do for each again. Let me scroll down a bit. For each current equals, and the union is basically saying just throw everything together, right? So it's just going to be result add current. So there's no filtering, there's no if, there's no else, right? Just always add them, add the elements of both of them, right? So we're starting with that one, and then to whatever it is, we're just going to add all the elements to this, right? We could have done it the other way around, right? We could have started, I believe we could have started with this, and we could have called for each on that. I think it should be the same. Yeah, it is the same, but I'm just going to do that because union, you know, it's commutative, right? So it doesn't really matter which way you do this. Okay, now let's do the intersection. Same as always. Remove that. Remember what the intersection is. It's this, but we already made this mistake, right? So it's actually empty. So we're going to have var result equals empty, right? So let's remove that one. All right, intersection. So over here, cut it out. It was over here. Paste that over here. It's not an override anymore. And let's implement it as always, as we have seen before. We're going to have var result, and the result is going to be empty, as we have just seen, and we're going to return result in the end. Okay, so let's have the traversal, right? Current equals. Now it's going to be pretty much the same as the commented out code over here, right? So we're going to say if that element, I'm sorry, not element, current, then result equals result.add current, right? So basically it's the same as union, but we have a sort of filter in there, right? So we're not adding like blindly every element as over here. We're only adding some of the elements, right? So it's like a filter. Okay, and that's it. Okay, and let's now do the difference. Difference is over here. Difference went away. Let's go to difference. Okay, the default is going to be empty. Okay, remove that. Difference, cut that out. Very mechanical transformation, as we have experienced already quite a few times. Like that. Final def, all of that is commented out. And as you remember, the result was just an empty set. And we're going to return it. Actually, let me save this so that Scholar formats it for me. You know, the tests are going to be failing, obviously. Okay, so for each current, right, and it's going to be flipped, remember? So basically I believe I can do that. I can just copy that, right, and I can just flip this. There we go. All right, and now everything is green. Right, because remember, for this implementation we just flipped which code is in the if branch and which code is in the else branch, but for this one I just flipped it over here, right? We could have done the same thing. We could have said like if that is current, then just leave the result alone, only otherwise, you know, add it. But this is more code, and it's not that more code is always worse. It's more like in this case, like you see like the dualities are, right? So the flip is over here now. Okay, let's remove that. Okay. All right, let's just keep going. Okay, so we have is subset of. So basically we want to get rid of every abstract method. So let's remove is subset of. Let's go down and see, okay, is subset of, by default it's true. So we're going to start with a true. Remove that. Cut that out. Go over here. Where were we? We were somewhere over here, right? Right. The cool thing is that we don't have to touch is superset of, right? Because it just relies on is subset of. So when we change the implementation, as soon as it's correct, is superset of is going to be correct by default. Okay. So let's do that over here, and yeah. So let's comment this out. So let's remove this line. Okay. So remember the result was true, right? And we're just going to return it back every time. Every time it's going to be the same for each current, right? Over here, and the implementation is going to be result equals result and that current, right? So it's basically the same over here, the same as over here. There's an end, right? What is happening? Oh, it's not an override anymore, right? Forgot that. Okay. Humans are not good at mechanical transformations. I'm sort of falling asleep over here. I hope that you are not. All right, the next one is size. All right, this one. You know, in fact, let me just do this one. Final def. I want to keep it like a bit different so that you also don't fall asleep. Size equals var current equal not current. It's gonna be result equals 0, right? We're gonna return the result. I'm gonna do for each current. We're just gonna do result equals result plus 1. Okay, this should be fine if I remove the others. Where's my size? Over here. Just remove that. Remove that. All right, now it's fine. And if we look at it closely, actually, for the size, we're actually not using current, so let's use an underscore here, right? And this technically, you know, this is the same code, plus equals 1. but I sort of want to leave this one over there so that you see the similarity, because in a few videos from here we're actually also going to get rid of for each in a sense, and we're going to revamp this code yet again, and we're going to have a way more functional approach without any silly bars, because if you start looking at this right now, the fact that we always have the structure var result, we do something with for each and then we return the result. Here var result, we do something with the for each and then we return result. So this is another sign. This is the sign that we're not done abstracting this away, right? There is still enough similarity there. All right, let's see what's left. So we have size, we have is empty, we have non-empty. Okay, singleton. Okay, so even though the next one is singleton, and you could implement this with for each, we probably really shouldn't, because the implementation is going to be really weird. We're gonna need to distinguish if we're empty or not, and if we're not empty, we'll have to start counting, right? To start counting how many we will basically encounter, right? And the implementation is going to get weird, because all we need to do is if we have one element or not. So we'll need to traverse the whole thing just to figure that out. So if it has like a million of elements, then we would need to to do millions of operations just so that in the end we can say no, it's not a singleton. So we're gonna leave this one alone, okay, for now. Sample is also not going to do anything with for each. It basically has to distinguish between if it's empty or not, and if it's basically what it currently is already doing, right? Sample, remember, sample just gives the element if it's this one, and it gives something else if it's that one. All right, so it looks like we moved all we could, or at least all we should, to for each. The problem now, well, it's not really a problem. It's just that I don't really like the fact that partially some methods are defined on the set alone over here, and some of them are defined in each individual branch, right? So some of them are defined on non-empty, some of them are defined on empty. I don't really like that. So we're gonna move everything to the trait, and the code is gonna get like a bit less pretty, but it's gonna be it's gonna be less pretty to write, but it's going to be easy enough to read, and then our readers, which is going to be us in the next video and in the next video and so on, it's just going to be much easier to know, okay, everything is in the trait, and this is just an implementation detail just so that we can link elements to each other. So let's start with for each. So let's remove for each from here, and let's cut it out from here like that, and go up where we define it over here. Let's just paste it in like that. And it's not going to be, it's still going to be final, but it's not going to be an override. Okay. Now over here, what we could do is we could pattern match, right? We could pattern match on, is it an empty set or not? The thing is that we need to be really careful with pattern matching over here, because remember, pattern matching is just a fancy syntax for equality in the end, right? And equality, especially for large sets, can get very expensive, right? So what we're going to do instead is we're going to do this pattern matching sort of manually. Okay, so let's comment this out. And let's say, actually, let me indent this brace myself so that it's just easier to follow. So we're just going to say if non-empty, right? Because that's the only case when we have to apply the function at all, right? If non-empty, we're just going to do this block, and that's all, right? So if non-empty, and we have to be very careful, right? Because we could accidentally do this, right? Deconstruct the elements, deconstruct the set, right? Elements equal this. Right, but this is pattern matching. Remember, this is pattern matching, so we should be very okay. This is going to work. In fact, let me actually finish this, right? So basically, I can actually move these two lines down, and then we're done, right? Like this. Let me remove some empty lines like that. Okay, so we're actually done, right? So it does the same thing, but this is pattern matching, and we want to avoid it because it's expensive, right? So we're going to say over here, equality is expensive. And therefore, we're just going to comment this out, and we're going to say non-empty set equals this dot as instance of non-empty, right? And remember, every time you say an as instance of, you're basically turning the compiler off. And in this case, it's safe to do so because we already checked for non-empty. And if somebody changes our code, if somebody removes this if accidentally, right, or we do this later when we're tired or something, then our test will fail, and they will let us know, hey, you're not allowed to do that. Okay, so we're just going to rip out the element ourselves, right? Non-empty set dot element, and we're going to do the same thing for other elements, right? It's going to be non-empty set dot other elements like this, and it should be exactly the same code. In fact, what I'm going to do is, let me do this. I'm gonna go back to this implementation like that, okay? And what I'm gonna do is I'm gonna make sure that pattern matching is not gonna compile. Even though like these, you know, empty and non-empty, they are private, still I can make this mistake over here myself. So I'm gonna at least make sure that I can't make this mistake. So what I'm gonna do is I'm gonna go to the companion object of sets, right, which is you know, over here. Let me do that real quick. Like that and like that. Okay, so this is the companion object of set that has a factor and has two of these private instances of this ADT, right? So what I'm going to do is I'm going to make sure that the set, the companion object, has an unapply method, right? And it's going to be private to this, and therefore we're not going to be able to access it, right? So I'm going to do unapply. And usually, if you implement pattern matching like this, then you will have over here, you will have a set. But I'm just gonna make sure that whatever you pass in, it's just not gonna work. Okay, so it should produce an option, right? An option with a tuple of string and a set. Okay, and I'm gonna say equals. And what I'm gonna do here is I'm gonna say pattern matching not supported. And pattern matching not supported is just gonna be a tiny private def over here, which is gonna throw an exception, right? So it's gonna be private this def pattern matching not supported. Nothing equals sys.error. Pattern matching on sets is expensive and therefore not supported, like this. Okay, so this didn't help, right? So remember, I want this code not to compile. This didn't help, so we need to keep digging. We need to copy that, right? And we need to go over here in the non-empty set. No, actually, let's go to empty set first. Let's go to empty set, open that, put over here. Didn't help. Okay, and then this one. Let's go over here. Didn't help. It didn't help because I added to the class. Like over here, this was already an object. I actually need to add it to the object, right? So I'm also going to have a private object, not empty, right? So let's just move this unapply over here. You know, rewatch the video about pattern matching in case classes if you have no idea what I'm doing now, right? So now it's going to say, hey, over here, remember where I left this comment, equality is expensive. Now this is not going to compile, right? Because it's going to tell me that, you know, it's a type mismatch. Basically, the compiler is completely confused, right? So I need to remove that and do that instead. And now everybody's happy, and we can't make this mistake. And because it's private methods, we don't actually need to test them. Which might actually ruin our coverage, maybe. We'll see. Now we can remove this to make the code a little bit more beautiful. All right, now let's do singleton, for example, final def singleton, and we're just gonna do same thing over here. Actually, maybe we don't even need this. Okay, so let's select this. If it's empty, then we're just gonna say false. Otherwise, we're gonna need a scope over here, right? And we're gonna do the same trick like here, right? So we basically need to do the whole deconstruction ourselves, right? We're gonna have to do this, right? And we're gonna say other elements is empty. I believe that should be fine. I mean, we have to remove the other implementations. This one. All right, let's see. Yeah, it's fine. And in this case, we actually don't even need, like in this case, we used elements in our other elements, but over here, we don't actually use the element, right? So we can just do that. Okay, so we're left with hash code, which we can just cut out and put to the top. I believe it should be fine. Hash code. Let's put it next to equals. Let's put it over here. Oh yeah, we can't access that. All right, so let's do this. And let's say, let's just go if is empty. Let's do 41. Otherwise, let's just do this whole deconstruction dance. This one. As I already mentioned, the code is not actually going to be more beautiful, but I sort of want to keep like all of the functionality in one place. All right, and the last one that is left is the sample. Okay, where is the sample? There it is, sample. So let's remove that. So now this class is basically a one-liner, and the same one for, where is it? This one. I mean, it's not a one-liner because it contains the unapply. All right, but basically, if we go up, that's too much up. There it is. Sample. It's over here. It's gonna do the same thing. So I'm gonna do if is empty, none. Otherwise, I'm gonna do the deconstruction thing. Just that should be enough. And just gonna do sum of element. And that should be enough. We actually don't need those curly braces over here. For unit, we don't need them here, but I prefer to make unit shine. So it's gonna be fine like this. For this one, we also don't need the curly braces. What else? Yeah, everything else pretty much needs those curly. Okay, this one doesn't. You know, I don't want to use curly braces. You know, I actually don't really like braces, so I'm trying to use as little as possible of them. It's not a popular choice, but it is mine to make. You can do whatever you want. All right, so I believe we're actually done. Let me check. Hold up. Have we done this? Have we done? Oh, we actually forgot to rewrite the test. So because we have this Varargs thing, we actually can rewrite our tests. And I'm going to do all of them. Or maybe I will do all of them. Let's see. So okay, so for example over here, so instead of set.empty first, we can do I'm gonna mark all of them, and it's gonna break some of them, right? So I'm gonna mark every time I say set.empty at first, and if you see over here it says found 7 matches. So what this is actually doing is set first, right? Like this. Now some of the others might not compile because it was actually at first, at second, whatever, but actually maybe it will compile. Right, it actually will compile because it's going to be like this: set first, add second. That's fine, but I don't want that either. Oops, that's not what I wanted to press. All right, I wanted Alt F3 and not Alt F4. Right, so set first dot add second is actually set first second. Right, let's keep looking. All right, set dot empty add element. Right, that's pretty much set of element, right? Let's keep looking. First, second, that's fine. First, second, that's fine. Over here, set.element add element. All right, that's pretty much set of element. What else? Empty set add first, add second. All right, so let's do this. That's empty sad. Oh no, that we actually can't change this one, can we? Yeah, we can. Yeah, why not? Let's just mark all of them. Let's just do a set of first and second. Okay. So green. All right, over here, like this is where we actually see the value. Let me actually do this. Oh no, let me not do this. So every time we add A, B, and C, it's actually set of A, B, C, right? And every time we add B, C, D, it's actually B, C, D, right? So set of B, C, D. Sublime was jumping around a little bit, but that's fine. Same over here. Set of B, C, right? Set of B, C, same thing. What else? That's fine. That's fine. Over here, that's just set of A, and that's just set of D. That's just a set of a random string. Oh, something broke. Oh, interesting. Let's just go back. I don't want to start figuring out why it broke. All right. Okay, let's try that again. Set of empty add random string is pretty much the same as set of random string. Okay. There we go. Still green. Okay. That's just A and B, that's set of A comma B. What else? That's fine, that's fine, that's fine. That's fine. For each is fine. Okay, maybe actually everything else is fine. Okay, so the only one that doesn't make sense is actually Varargs, because Varargs actually doesn't test anything now, right? So this is the only one that we basically need to reverse. We need to add A, add B, add C, and this is the only one that actually, you know, needs to do the adding, and now we have to actually add it on empty, right? Like this. All right, I believe this is all for today. Let me review this real quick. Maybe I find something that we can improve, because as always, I wanna commit it and push it. All right, I actually believe that we're good, so I didn't have to change anything. Let's exit from SBT. Let's do git status. We change only these two files, as always. Let's commit both of them. Actually, I prefer to do add, even though like basically add tells Git to start tracking new files. In this case, there are no new files, but still, I believe just to see them green makes me sleep better at night. All right, so commit everything with a message of video 3, and this is going to be for each. I'm just going to call it for each. And by the way, usually you would use camel case. So for each, you know, should be actually, you know, the E should be capital, and you know, some languages have it as capital. You know, for example, JavaScript has it as a capital E, right? Scala doesn't, so I decided to stick to that. All right, okay. So video 3 for each, commit it, push it, and there we go. It's pushed in a second. So let's see that over here. Okay, let me refresh. Okay, so we have 5 commits. We have video 1, video 2, video 3. If we click on that, we see everything that changed. As always, we revamped pretty much everything over here, and you know, we changed some tests at some point. Where is it? Changed some tests. Basically, this is the Varargs stuff, where you see like all these, you know, one line changes that Sublime help us do. And that's basically it. And let's see what we're going to talk about the next time. I believe in the next video we're actually going to start talking about generics, and that's going to be a fun one. All right, like this video if you did, subscribe if you want to improve the developer inside you. Most importantly, take care.